Dear students, today I am going to explain a very important part in the second chapter, and it is nothing but it is photoelectric effect. So, as name indicates, photo relates to light, and electric, current and effect. So, it is defined as the phenomenon or the process when light radiations fall on certain materials, fall on certain substances, there is the generation of electricity by the emission of photoelectrons. So let's see first the definition. So it is defined as the process of emission of photoelectrons when light radiations or rays of suitable energy falls on some substances. So this is very important to note that rays of suitable energy falls on some substances. So the incident rays, the incident light must have some definite amount of energy. Some substances which results in the flow of current, which results into flow of current. And children, such substances are called as, such elements are called as photosensitive elements. Example, silicon and germanium. There are different other compounds also, but silicon and germanium are most sensitive substances or elements which exhibits photoelectric effect. So they are the most suitable substances. Now, how to demonstrate? Actually, children, see that this is the photosensitive, this is photosensitive material, and let the incident rays, it can be from sunlight or it can be from the tube light or bulb, anything, or ordinary light. You all must be knowing there are the calculators who have dual mode of power supply. They have the battery and they have also a small chip of silicon, and the ordinary light or light from the room falls on it and it starts working. So here this is the incident ray. These are the incident. These are incident rays on the surface, and as a result of this, there are the photoelectrons. They are the photoelectrons. So these electrons are called as photoelectrons. So this is photoelectric effect, and the electrons, electrons are negatively charged, so they are attracted. They are received by the positive plate, and as a result, what is there? What is current? Current is nothing but the flow of electrons in a particular circuit, and so this is the basic introduction about the photoelectric effect. To study the photoelectric effect, some special type of devices or which are called as photocells are used on small scale for the verification, and so they have children, they have this type of, you know, this is a photosensitive material, and it is connected. It is connected to the battery. This is negative, this is positive, and here there is the one more. This is, let this be negative, this is positive, and it is enclosed. It is enclosed in a glass chamber. It's glass chamber, and when the light rays now from any this these are incident rays, and so then what happens? The photoelectrons are emitted, and as it is negatively charged, it is positively charged. What happens? These photoelectrons, they are attracted. They are attracted. They are attracted by the positive anode. And so what happens? There is the flow of electron in the circuit, and so if we put here, ammeter, so it indicates the flow of current, and so this is the exhibition. But there are certain conditions also which is. So children, there are certain conditions for the photoelectric effect, and the conditions must be fulfilled. So there are some conditions, and so conditions are: first, the substance must be photosensitive in nature. So the light rays must fall on the photosensitive material. If the material is not photosensitive, so there will not be photoelectrons. Silicon, germanium, and certain few elements, they are photosensitive because the electrons in the outermost orbit, they are bonded with poor force of attraction, and so the requirement of energy, it is very, very less, and just by the little amount of energy, the electrons, they are ejected out of the valence shell, and so they start moving in the circuit, and so there is the photoelectric effect. Second point, the incident rays must have certain minimum energy or frequency, certain minimum energy or frequency capable of causing emission of photoelectrons. The incident must have certain minimum energy or minimum frequency, because the different metals have different energy requirement, and so this certain minimum energy, it is called as threshold. It is called as threshold frequency or threshold energy. Certain minimum amount of energy required, and if it is not there, that is, it is less. If the incident rays have less energy, less frequency, so no photoelectric effect will take place. Likewise, in case of solar cells, for example, solar cells, they have the photosensitive material, they have the chips of silicon and germanium. You all must have seen the street lights, parks, and persons, they are installing solar plates. And so, in case of night, no current is produced because in night there is no sun. So this is called as threshold frequency or threshold energy, and it is having this H nu naught. This is represented by H nu naught. Now third point is different materials have different requirement of threshold energy. Meaning is all the photosensitive materials do not have same amount of threshold energy requirement, and it varies from, meaning is, or you can say it varies from element to element. It varies from element to element. Now next, children, very important part, the extra energy is imparted in providing kinetic energy. The extra energy present in incident rays is imparted as kinetic energy to the photoelectron. So the extra energy, children, the extra energy is imparted or it is used in providing the kinetic energy. See how? You have seen in the quantum theory that E is equal to h nu. You know this thing, E is equal to h nu. So this h nu, see very carefully, or we can write mathematically, h nu is equal to h nu naught plus half mv square. It means this is what? This is kinetic energy. It will be used in imparting energy to the photoelectrons, and this is called as threshold energy. So this is these are some of the points, and if you see some more points, see how. Now another very important point is that for the photoelectric effect to take place, the incident rays must have the minimum frequency, minimum frequency equal to the threshold frequency. And so if it is, then see the conditions. So first is, if h nu is equal to h nu naught, then photoelectrons will be emitted. Photoelectrons will be emitted. There will be emission of photoelectrons. Now second is, if h nu it is less than h nu naught, so there will be no photoelectrons emitted because the energy is less and the ejection of photoelectrons will not take place. Now children, now the third condition is that if h nu is more than h nu naught, so here this is the best condition for the ejection of photoelectrons. And why it is so? Because if it is there, then what will happen? The remaining frequency will be utilized like here. So it will be there. So this is the condition. Now, children, the last point, the number of photoelectrons emitted depends on the intensity of incident rays. Depends on the intensity. Intensity means the sharpness of the light rays. For example, the photoelectrons are emitted less when at the morning hours, in the evening hours, and so this is there. Children, last part we'll see, and it is nothing but the applications. Applications of photoelectric effect, and so you all know, you all are aware of solar cells or solar energy. So first is, of course, in SPV, solar photovoltaic cells, or you can say in generation of electricity by allowing the sunlight to fall on the solar photovoltaic cells. This is one. Second, in burglar's alarm. Burglar's alarm means to prevent from the theft, etc. It was used long back, but now security has been done by many things. So burglar alarm means, suppose if there is a limited place, some entry, and here there is this installed, the photocell, and if light here, if light, say bulb is there, bulb, and the light, it is not seen, it is open to persons, we are unable to judge it. So what happens, as long as light is falling on it, and here, and this is the entry, this is the entry point, and so the photoelectrons are emitted, electrons are affected, this is the negative and this is the positive. So photoelectrons are going on, and so the current is flowing. And in this circuit, electric bell or alarm is installed. Alarm is installed with the relay switches. Alarm with relay switches, relay switches, they are automatically able to change the direction of current. So as long as the current is flowing, what happens? Relay is off. Relay is just they are capable of working in reverse condition. So as long as current is flowing, relay is off. It is some sort of electromagnetic device, very small device. And when some persons enters here, rather burglar or theft or thief comes here, so what happens? If a person comes here, what happens? This supply will be cut off, and so this relay will be on, and so it alarms, and so this is the application. Then there are children many more to locate the far away distances, locate the far away distances by astronomical machines, and so they are based on the photoelectric effect. So this is about the photoelectric effect.